Right, we're going to be taking a look at our right triangle problems and our angle problems, exact value with half angle identities. And this is the last set of identities on your sheet. We will not be using these in proofs. We will only be using them for exact value. So sine of a over 2 is equal to plus or minus the square root of 1 minus cosine a over 2. Now it's because of the square root, we do have the plus or minus. We actually are going to need to determine which one it is for each angle based off of the quadrant. So that's going to be a tricky part, especially with the right triangle aspect. Cosine of a over 2 is plus or minus 1 plus cosine of a over 2. And then tangent of a over 2. Also plus or minus, and you'll notice it's really just taking the sine dividing by the cosine. So that eliminates the denominator of 2. So they all look kind of similar, which will be helpful and also tricky when you're memorizing them. Just be aware when you're learning these. I'm going to need all students take calculus to determine things about the quadrant. So we're going to start off doing angles. A lot of these angles we could have also done with sum and difference. A few of them that we can't. And our directions are just find the exact value. So the first one is sine of 165. This one you could do with the sum difference identities. I'm not going to make you do a lot of rationalizing here, so the answer may look a little bit different. And that's fine. If you were to calculate it, would be the same. So sine of 165, first 165 is in quadrant 2. Sine is positive in quadrant 2. So what that means is I'm going to have a step in between that I'm going to write out what angle measurement I'm using. But if sine is positive, that means that I'm going to use the positive version of the identity. And then all you're going to do for the middle step is to make it look like that angle over 2 situation. So multiply 165 by 2. That's going to give you 330. So I'm going to write here 330 divided by 2. If I were to resimplify that, 330 divided by 2 does give me 165. And in fact, I'm just going to make that 330 into a slightly different color. 330 is taking the place of a. So when I go to plug it in the function, that's what I am going to be, or the identity, that's what I'm going to be plugging in. So when I go to plug in, I'm going to do 1 minus cosine of 330 and then I'll evaluate that. So I had a second round where I need to worry about the quadrant. 330 is in quadrant 4. Cosine is positive in quadrant 4. So that answer inside will be positive. And I'm just going to put parentheses around that because it's minus and then the positive value. And then we're going to put in root 3 over 2. It's a 30-degree reference angle. Now I'm kind of going quickly through some of those other steps like the reference angle, the quadrant, and things like that because those are things that you've done in the previous unit. And then something that will be helpful here, kind of like we did with the proofs, I'm going to multiply the top and the bottom by 2 to get rid of the fraction. So similar step to how we did it with the proofs, but I can do it at the same spot. Because this is not a proof, so I don't have to show every single step for my simplifying. And then I'm just going to square root what I can, so I can square root the 4 and that's going to give me a 2 in the denominator. You can leave your answer like this. There is a way to get the radicals out of the numerator, or that radical in a radical, but you can leave it here. Really what I'm testing you on here is not the radical aspect, but the angle and exact value aspect. All right, so we're going to do 2 more like that. Another one, a cosine and a sine. Same idea, cosine 202.5 degrees. Again, you want to determine your quadrant. This is in quadrant 3. Cosine is negative. So I'm kind of skipping over that middle step for a second, putting the negative sign with the identity that I'm going to use. So determining if it's a plus or a minus, it's not both. It's going to be 1 plus cosine of whatever angle that I get divided by 2. So I just really need to figure out that angle. And again, to figure out that top angle, we're doing the 202.5 times 2, which comes out to 405 degrees. So that's what I'm going to end up plugging in here, because that's the angle that's being divided by 2 to then get back to that 202.5. So you're plugging in that angle that's on the numerator. Now you might also want to take a minute and do the 405 minus 360 to get 45, or get that coterminal angle. I think that's always a good idea, so that you kind of think about, okay, what quadrant is it in? What is my reference angle? In this case, it's 45 degrees, so that is the reference angle. So it's 1 plus cosine 45 is root 2 over 2. And then same thing again with the denominators. I would multiply top and bottom by 2 to get rid of that denominator. And then you'll end up square rooting just the 4, or taking the square root of the 4 in the denominator, leaving your answer like so. And then there's one more angle type that we're going to do, or one more identity we're going to use with this, and that's the tangent, but same procedure, just different trig function. Now, just like before, I would do quadrant, later on actually coterminal angle, so this is quadrant 3. I think 12 pi over 12 and where that's going to fall. Tangent's positive in quadrant 3, so when we skip over to doing the radical information, you don't have to put the positive sign in front, but just realize that you're only doing the positive version. And that's going to be 1 minus cosine over 1 plus cosine of whatever angle that we get. Now the radians are easier here to just figure out that angle. We're going to multiply the denominator by 2, so we get 13 pi over 6 divided by 2. I meant to put that in a different color, so you can still see that. So I'm going to fill in the 13 pi over 6. Once again, I'm going to need to worry about, or think about, the idea of the coterminal angle. So if I take 13 pi over 6, subtract the 12 pi over 6 off, which is my 2 pi, I once again get an angle in quadrant 1 that I can work with there. So pi over 6, or 30 degrees. It's going to be root 3 over 2 here. And on the denominator, same as before, multiply. Now, normally I would say you would go ahead and rationalize this, but with this section, we're going to stop here. Because that's enough simplifying. You've done the work of getting the right positive or negative outside the radical, the right exact value inside, so you don't need to rationalize. So I think the tricky part about the angles, I think, is the sign, the positive, negative, and then that middle step of multiplying the angle by 2, you have to make sure you use that angle when you're doing the exact values in that second part. All right, so this concludes the angles video. The next video is going to talk about how we can use this identity with triangle problems.